Okay, so question 9 and the last question of this paper is express 6x minus 27 over 4 minus x square in the form a plus b x plus c square, where a, b and c are constants to be found. Okay, so this is your equation and you need to transform it into the completed square form. So let's begin. 6x minus 27 over 4 minus x square. Okay, this is your equation and you need to change it into completed square form. So how do we do this? Whatever is the coefficient of x square, we take that common. So here it is minus 1, so x square minus 6x plus 27 over 4. Okay, then this is your step 1. Second step that we do is to half the coefficient of x and square and add and subtract that. Okay, so the half of 6 is 3, so we will be squaring and adding 3. Okay, this minus 1 we took common from the whole equation, so it will just be carried forward as it is. So x square minus 6x plus 3 square minus 3 square plus 27 over 4. Okay, then keep this bracket. Okay, this is giving you a complete square, and that is x minus 3 whole square minus 9 plus 27 over 4 then we will be having x minus 3 whole square, then simplifying this, minus 9 plus 27 over 4. So making a common denominator, multiplying and dividing this by 4 will make it 36 over 4. So minus 36 over 4 plus 27 will give you minus 9 over 4. And this will give you minus of, when you expand it, the minus 1 you are again multiplying it inside, it will give you plus 9 over 4. So now comparing this with a plus b x plus c, a plus b times x plus c whole square. Okay, just making it into one more step, simplification, because we have the constant term first in this, so we are writing that as it is, so our comparison is easy. So from here we will conclude a is your 9 over 4, b is minus 1 because there is nothing here but just a minus, so your b is minus 1 and your c is minus 3. Okay, so this is the result of your first. You change it into completed square form and you compared it with this standard form. You get it to be a to be 9 over 4, b to be minus 1 and c to be minus 3. Okay, now let's get back to part B. Figure 2 shows a part of a sketch of curve C1 with equation this. So this is the equation of this curve. Given that the point P is maximum point, so state the coordinates of P. So how do we find the coordinates of P? It's very easy. For everywhere when we need to find the coordinates of P, what we do y prime equals to 0 Okay, from here we can get the coordinates of the stationary point. Yes, the maximum or the minimum. For any curve, we call this to be stationary point, whether it is a maximum or a minimum. But when we're sure of its nature, that means it's a minimum point, so it's like this. Sorry, it's a maximum, so it's like this one. Okay, but here there is one more way of doing it. As we have the completed square form, so we know how to extract our coordinates of stationary point or maximum point from the completed square form. So whenever you have the completed square form, you put this x minus 3 equals to 0. You will get your x coordinate of your turning point and your 9/4, whatever this is, y is equals to 9/4. This is your y coordinate. So from completed square form we get square form, your coordinates of point P are 3, 9/4. Okay, this is your part B. Now part C, figure 2 also shows the sketch, part of a sketch y is equals to cos kx. This is the curve of cos. We know how the curve of cos is like this. So this is your curve of cos kx. Okay, in your sine, cos, tan curves equations, this anything that is multiplied inside with the angle, this represents frequency or number of cycles. Okay, so that means there is no a, this, what is the standard form? That is a cos bx plus c. So this represents baseline. There is no baseline other than the x, the original coordinate, the origin line. Okay, and there is no a, that means this, there is no amplitude other than 1. Just there are some different, like there are not number of cycles, just one cycle in 2 pi, but there are more number of cycles or less number of cycles. Okay, where k is a constant and x is measured in radians. Given that c1 and c2 intersect on the x-axis at point A and B, state the coordinates of B. Okay, as your curves, both the curves meet the coordinates axis at A and B, so we need to find the coordinates of B. So let's first take this curve, and as we know that this at this line y equals to 0, so if we put in the equation of the first curve y equals to 0, we will get A and B coordinates. Okay, so we have y is equals to 6x minus 27/4, minus 27/4 minus x square. So at x-axis y equals 0, so this is equals to 0. So multiplying this whole equation by 4, we will be getting 24x minus 27 minus 4x square equals 0. So substituting, like arranging it, multiplying whole equation by minus 1, 4x square minus 24x, sorry, minus 24x plus 27 equals 0. So solving it out, we will get two factors, minus 18x minus 6x. This will, upon multiplication, this will give you 108. That is like the product of 27 times 4, and upon adding it will give you minus 24x. So you can either use the breaking of middle term, or you can use the quadratic formula. Okay, so taking 4x common, no, not 4x, 2x common. So 2x common will give you 2x minus 9, minus 3 common will give you 2x minus 9. So this will give you 2x minus 9 times 2x minus 3 equals 0, and this implies x equals to 9 over 2 or x equals to 3 over 2. So these are your two values, two x values for where the curve meets the coordinate axis, the x-axis. So let's plug in these values, like show them on the curve, 3 over 2 and 9 over 2. So for sure this will be your 3 over 2. So let's write the a point to be 3 over 2 comma 0, and this point b will be 9 over 2 comma 0. Okay, y coordinate is 0 and x is 9 over 2. Okay, this is one thing that they asked us to find, the x coordinate of p, that is 9 over 2. State the value of k. Okay, for this as well, for this reason as well, what we will be doing, we will be substituting the same 0, y equals to 0 in the second equation as well, that is the y equals to cos kx, because on this curve as well, the on y-axis we can find the point b's, so we can substitute that to find in the value of k. Okay, so first write down that x coordinate of b is 9 over 2. Okay, one thing. Secondly, as on x-axis y is 0, so y is equals to cos kx will also give you cos kx equals 0. We know that kx will be equals to cos inverse of 0. Where is cos 0? Cos is 0 on pi over 2 or 3 pi over 2. Okay, 90 degrees or 270 degrees. So from here, let's take any one value. Kx will be equals to pi over 2. So we know the x value. Okay, we can plug in any x value, either this or this, to find the value of k. So let's substitute the same 9 over 2 for the coordinate b. So k times 9 over 2 will be equals to pi. Okay, no, not any value, because we are taking pi over 2. So this is the first value. So this is your representing. This is representing 3 over 2 is representing pi over 2, and this 9 over 2 is representing your 3 pi over 2. So when we need to find when we are taking pi over 2, so we need to take the x value over there to be 3 over 2. Okay, so as to find the value of k. So k times 3 over 2 equals pi over 2. So this 2 and 2 can be cancelled. So k will be equals to pi over 3. So this is your value of k. Okay. Now next, state the period of C2. C part 3. This is C part C. 1, C2 is this period. For the period, we have a formula that says 2 pi over b, where what is b? If you remember here, I wrote the standard form of your cos, in which b is actually the number or the variable that is being multiplied inside with the angle. Okay, so this is b, so here b refers to k. So if we write 2 pi over k, we will get the period. 2 pi over k is means 2 pi over 3, and that will give you pi and pi will be cancelled, and period is 6 in this question. Okay, so we found all the three parts of your C. Now let's take this. There is a line segment L that joins P and B. The region R shown shaded in figure 2 is bounded by L, C1 and C2. Okay, they are talking about this line now. They say there is a line PB and there is this curve, a part of your curve C1 and curve C2 is this, and this region is bounded by 3 curves, means one line and 2 curves. So what are they asking us is, they're asking us to use inequalities to define R. So we can use inequalities to define R once we know the equation of line L. Okay, so for line L, what do we need? We can write the equation of any line if 2 points are given. So point P we also know. We found point P in the start. Okay, we'll substitute in that and use the point B, that is 9 by 2 over 9 by 2 and 0, and we'll find the slope and we'll find the equation of this line L. Okay, so let's find it out. The coordinates of P are 3 and 9 over 4. This is point P, and coordinates of point B are 9 over 2 and 0. So line L would be, slope of line L would be y2 minus y1 over x2 minus x1. So 0 minus 9 over 4 over 9 over 2 minus 3. So solving it out will give you 3 over 2 in the denominator minus 9 over 4 over 3 over 2. So you will be finding m to be equals to minus 3 over 2. Slope of your line will be minus 3 over 2. Slope of your, okay, the equation of line would be then y minus any one point we can substitute. Let's substitute in the point B. Y minus 0 will be equals to minus 3 over 2 times x minus 9 over 2. So this will give you y equals to minus 3 over 2x plus 3 over 2 times 9 over 2 minus 3 over 2x plus 27 over 4. This is your equation of line. Okay, L. So let's copy this and get back to your curve. Okay, write it over here. right beside this curve. Okay, and decide for it. For the region R, where we are supposed to go, like we need to go below the line, so the y values are decreasing. So for this particular equation, y should be less than or equals to your minus 3 over 2x plus 27 over 4, because we need to go below the line to get to the region. Okay, now look for your second curve. Your second curve is this one, and what is the equation of this curve? 6x minus 27 over 4 minus x square. 6x minus 27 over 4 minus x square is equals to y. So from this also, do we need to go down or upwards to get to the region? Yes, our y values will be decreased when we'll go down. So for this particular, it will also be less than or equals to. Okay, now let's get to the third curve that is encompassing this region R. This is your curve of the equation y is equals to cos kx, or you can write, substitute in the value k, that is pi over 3. Okay, so for this region we need to go, do we need to go up? Yes, we need to go up, like the y values are going to increase. So for this reason, y should be greater than or equals to cos pi over 3x. Okay, as the lines are solid, so I am specifying greater than or equal to, but you but in these questions, just if you will just specify y is less than or y is greater than, that would be enough. Okay, so but as we know for the fact that if you have a solid line, then it would be greater than or equal to or less than or equal to, but if it is a dotted line, then it should be greater than or less than. Okay, so this is all about your region R and all about your paper P1, paper 11 for pure maths, January 2025, WMA01 paper code. That's all. For any suggestions, any queries, you can comment below. For solved paper as well, if you want that, you can also ask in the comment box. Okay, thank you very much, and Allah Hafiz.